Perfect. So during our last class, we talked about forces on submerged surfaces. That was our last class. And today we are going to do a few problems on submerged surfaces. So we talked about two kinds of submerged surfaces, a plane submerged surface and a curved submerged surface. Today we will do a few problems on that. One problem on a plane surface and maybe on a curved surface. Actually, if you can do a problem on a curved submerged surface, then the plane submerged surface is just a part of it. So it becomes easier. So let us start with the curved submerged surface. And my purpose to solve this problem here is twofold. One is to see the application of what we have done. Force on a submerged surface, that's the topic which we studied, and we would see its application. My second purpose here is to give you an idea about how to properly tackle a problem and how to solve it in a systematic manner so that you don't miss anything. So let's say we have this problem in front of us. We have a gate. This is our problem one. We have a gate which is hinged at O. It's a black curved gate, if you would see. X and Y are the axes which I have drawn. My origin point is O, which is at the hinge. This gate has a width of constant width of W is equal to 5 meters. Now this width of the gate is inside the plane of your screen which you are looking at right now. Okay, so we are looking at in this way, so you are looking at it from here. So this is 5 meters. You are looking at it like this. Now it's a curved surface, so equation of the surface is x equals to y square by a. For this case, for this particular problem, let's say a is equal to 4 meters. Now the depth of water which is d in our case is 4 meters. You can see it from the problem here. Depth of water is 4 meters. Now the problem is, the question which is being asked to us is, find the value of force Fa which is required to maintain the gate in equilibrium, provided we have an assumption that we are neglecting the weight of the gate. So it's a simple problem, something like this, that you have a curved surface, okay, and then you have water on the bottom side. Now the pressure and the forces from this water would try to tip it like this, in this way. So what force Fa should be applied here at this end so that it won't tip? That's what we want to find. Okay. So if you would see from your mechanics, you already know it's a case of statics and it's a static equilibrium. So to do that, if you can find the moment about this hinge point O, okay, and if you would use moment equilibrium, summation of all moments 0, then you can find the value of Fa. But first of all, you would have to find that what are the forces due to this water which is at a height of, let's say, 4 meter. What are the forces due to it? That's the first thing which you need to find. And also, we studied during our last lecture that we are going to find the two components of the resultant force, the vertical component of the resultant force and the horizontal component of the resultant force. And then we would try to find out at what location they are acting. Only then we can find out overall moments because of these forces. We would have three forces. One force would be this FA vertical force. Second force would be the vertical force due to water. Third force would be the horizontal force due to water. And then the locations of it. Location of FA is known to us. It is at L equals to 5 meter. And then the location of FV and FH, this is something which we need to find. Now let's see how we would move ahead and what are the ways in which problem can be made a bit easier. So I would recommend that whenever you are solving a problem, those of you who were with me in first year mechanics, they also know, and I already talked about that in the class before in first year, but for those who are new, I always recommend that you start in a systematic manner. Go with what's given to you. क्या चीज़ आपको इस प्रॉब्लम में मालूम है, सबसे पहले वो अगर लिख लेते हैं उससे काफ़ी आसानी हो जाती है. हमको मालूम है विड्थ 5 मीटर के बराबर है, डेप्थ हमको मालूम है 4 मीटर के बराबर में है. Equation of the surface is also known to us, and for our case it's x equals to y square by 4. It was x equals to y square by a, and a is given to us, and that a is 4. Just to let everyone know that from now onwards, try to be on time. If you are joining late, then it would be really difficult for me to let you in the class. Try to be on time. Till 5 minutes is okay, but after that it really disturbs the complete class. Okay, so this is something which is given to us. Now, once I was discussing force on a submerged surface, I talked about that you have a surface and the vertical force would be force weight of the liquid above the surface. That's what I said. But if you look at this problem here, the liquid is below the surface. Okay, so no need to get confused with that. It is one and the same thing. The only difference would be now I need to find out what kind of forces are acting because of the liquid below in the vertical direction. That is one of the way to deal with this problem. But there is another way. There is another way through which you can simplify this problem, and let us see how we can do that. So let me make the FBD, force body diagram of this case. It was something like this, that I have FA acting here, and let me say that I have water till this height, and let's say this is my vertical force and this is my horizontal force. Okay, now I can change this system. I can change this system into an equivalent system. Let me see what kind of equivalent system is that going to be. Let me change that into an equivalent system. Okay. I can change it into this way. this system which is in the start, I started with it. This can be changed into this kind of system, where in this case B, and let's say this is case A and this is case C. My case A is my initial system force body diagram, and think of it, if it was submerged completely, then there is no force acting, no fluid force acting, and then from it you can just subtract this portion. You can subtract rest of the portion so that you have something like this acting, and now your forces would be reversed, your vertical force and your horizontal force. Okay, now location of your horizontal force would be y dash, location of vertical force would be x dash. So you can change your problem, which is here, into an equivalent system like this. You can do that also. So there are multiple ways of doing a single problem, and this is one of the way which I am going through, and I would suggest that you on your own try to solve the system which is shown in A. I'm going with another method, but it's up to you. You can do this one. So what we have shown is an equivalent system of A, that is B and C. The magnitude and location of the vertical force are given by the weight and location of centroid of the fluid above the gate. Similarly, for the horizontal force, it is given by the force on an equivalent flat surface. We talked about it in our lecture before, that if you want to know how much is my horizontal force acting, then it makes no difference if your surface is curved, if my surface is straight, or it is of whichever shape. The only thing you need to find, let's say for this curved surface, I want to find how much would be my equivalent horizontal force. You just need to take its projection, a vertical projection, and then you need to find its middle location. And that's where my horizontal force would be acting. And the magnitude of the horizontal force would be rho times g times the depth. So that's the case. Now, next point would be to always write the governing equations. Actually, I would suggest, it's just a suggestion, that even in your exam you go by this way. Now what happens, let's say if you are solving your problem in this way, it gives an idea to the examiner who is evaluating your exams, that okay, the student has an idea about how to tackle a problem. He knows about the physics of the problem, and he knows about the mathematical tools which are needed to solve this problem. And then afterwards, even if there are certain errors and you somehow couldn't reach your exact answer, then the examiner would have an idea that okay, no problem, maybe it happened due to some errors while calculating on calculator, or he missed a step or two because he was in a hurry in exam, but at least he has a very good idea about the physics of the problem and the mathematical tools required for the problem. So I would always suggest that you do your problem in a systematic way, as opposed to another student. एक दूसरे स्टूडेंट ने क्या किया कि साहब प्रॉब्लम तो बिल्कुल सही करना शुरू किया, लेकिन बहुत सारे स्टेप्स काट के शुरू किया. तो होगा क्या, इट्स अ पॉसिबिलिटी कि उनके साथ भी यही थोड़ा सा एरर हो गया और कैलकुलेटर में बजाय मल्टीप्लाई के डिवाइड हो गया, या एक डेसिमल इधर का उधर हो गया और आंसर डिफरेंट आ गया. लेकिन क्योंकि शुरू में कि उन्होंने प्रॉपर्ली थॉरली उसको नहीं किया था, तो प्रॉब्लम ये होती है कि एग्जामिनर के लिए बड़ा डिफिकल्ट होता है जज करना, कैसे मालूम हो कि इन्हें ये प्रॉब्लम आती थी या नहीं आती थी, बेस्ड ऑन व्हाट ही वुड डिसाइड. So that's why I would recommend that always be prompt and be systematic once you are solving your problem. So the governing equations here are that my horizontal force is pressure at centroid times the area. My location for my horizontal force, it's YC centroid location plus IC, which is moment of inertia about my centroid location divided by AYC. My vertical force is weight of liquid rho GV, and my X location is CG. For this case, water CG location. Okay, that's what this is. Few of the cases I already know that my Y location would be, let's say, at C, which is D by 2. I said that for finding the location of horizontal force, you just need to take equivalent projection of vertical projection and then go to the half of it. So it's D by 2. Area is going to be D multiplied by W, which is given to us as 5 meter, and moment of inertia about centroid. It's a rectangular object. This is already known to us. So let's say if you are not up to the speed with moment of inertia, then you can go to your strength of material, and even in your statics book you can go back to your applied mechanics and look at how to find moment of inertia. And even if you don't know that, then you can see that how basically moment of inertia is being found. So that is something which you can brush up. The other thing known to us is that horizontal force, it is going to be PC times A, which is going to be rho GHC times A. Area is known to us, so it is rho G D by 2 times D times W. And I would like you to do rest of the calculation, and I can just give you the value so that you can check if you are finding the right thing or not. So I'm missing few of the steps, and this is something which I expect you to do by yourselves. Similarly, you can find the value of y dash. I have already written it here, what it is equal to, and again some steps, and you would find out that this is equal to 2.67. You just need to plug all the values here and you would find that out. Okay, so now we know our horizontal force and the location of horizontal force. Now for the vertical force, we can find weight of the water which is above. As shown in figure C. So what we are going to do is we are going to find this weight. Now this weight would be equal to rho G times volume. We need to find the volume. To find that, first of all, we would find a differential volume. So we would take a strip and then we would integrate it over the whole surface. That's what we are going to use. Okay. So my differential volume dV for this case is going to be d minus y w dx. So my overall force, vertical force, which is equal to rho g times v, it is going to be equal to rho g times 0 to, I'm looking at the limits, d square by a d minus y w dx. Okay, I already know the relation between y and x. I know this relation. Okay, y is the function of x. I know this relation already, it's given to us. Okay, so again some steps and you would find out that it is something equals to 261 kilonewton. I have these steps in front of me, but I would like you to do these steps. Okay, and then you will find out. The challenge here might be to find this differential volume. ये एक चीज हो सकती है जो एक दो प्रॉब्लम के बाद कर्व्ड सरफेस के आपके समझ में आने लगेगा कि डिफरेंशियल वॉल्यूम कैसे लेते हैं. इट्स नॉट दैट डिफिकल्ट, बट अगेन आई वुड सजेस्ट दैट यू लुक इनटू इट. ये कैसे आ गया d माइनस वाई? वॉल्यूम के लिए मुझको 3 डायमेंशन चाहिए. तो एक लेट्स से ये कर्व्ड सरफेस था, एक तो डेप्थ था, w मुझको मालूम है, ठीक है, एक dx हो गया, और ये y वाली लोकेशन जिसको मैंने d माइनस वाई लिखा है, ये जरा सा देखिएगा ये किस तरीके से आया, ये d माइनस वाई किस तरीके से आया, आप ये देखिएगा, एंड देन यू कैन फाइंड आउट हाउ वी गॉट दिस वॉल्यूम. एंड वंस यू नो दैट, अगर आप इसमें कंफर्टेबल हैं तो कर्व्ड सरफेस कैसा ही आपको गिवन हो, कोई परेशानी नहीं होगी, आप बहुत इजीली उसको निकाल सकते हैं. कोई भी प्रॉब्लम आप यू कैन डू दैट वेरी इजीली. हॉरिजॉन्टल फोर्स निकाल लिया, हॉरिजॉन्टल फोर्स का लोकेशन निकाल लिया है, वर्टिकल फोर्स मालूम कर ली है. अब वर्टिकल फोर्स किस जगह पे लग रही है, लोकेशन वो मालूम करना है. So for finding x dash, which is nothing but cg of water above gate, क्या करेंगे? मोमेंट. पहले भी आप लोगों को लास्ट टाइम पे मैंने ये प्रॉब्लम कहा था, एक डू इट योरसेल्फ करके लिखा था कि ट्राई टू फाइंड आउट हाउ x dash location is found. Okay, you might have seen in your FM white book. I already pointed you to that there is a solved problem in your FM white where they have discussed how to find x location. So let me do that analysis here again. If let's say for this particular problem I want to find out the location of where my FV is acting, then it is very simple, it's quite simple. The only thing I need to do is to find moments, moment due to elemental force, which would be equal to moment due to resultant vertical force. So x dash, location of your resultant vertical force multiplied by your resultant vertical force, this is going to be equal to your elemental force multiplied by the location of that elemental force. So x times d minus y w dx. Okay, again you would solve some steps, you would do certain steps, and you can find out that your x dash would come out to be 1.2 meters. This is something which you can do and you would find it out. Now our final problem, what we had to find in this particular case, if you would come back here again, the whole question was to find the value of FA. To find the value of FA, what value of FA should be what should be the value of FA so that this gate would not tip over like that and it would stay like that. How much this vertical force FA should be applied. Now it is quite easy. We know all the forces which are acting. The only thing I need to do is, for equilibrium at the hinge location, I need to find moments. For FA, we would take moments about O. Okay, and we would say that summation of all moments about O location would be 0 because our system is in equilibrium. So minus L times FA plus x dash times FV plus d minus y dash times FH. This is 0, and if you would solve this problem, you would find that your FA is around 167 kilonewton. So I have knowingly missed certain steps of calculation. Those are nothing, just some number crunching. You just need to put certain numbers in the in your calculator and you can find these values. I've given you the final result just to check that you are following everything. Now that's your first problem. Before I would move on to the next problem, if you have any queries, let me know.
Sir, can you
Sure. Yes. And as always, I know it's a bit difficult if you are watching it, if you are attending this class on a mobile phone, then maybe it's a little bit of a challenge to look at the mobile and then make the notes. But for your own good and for getting maximum benefit, I would always suggest that instead of attending these classes, like if it's a meeting happening on, these are the classes, I would really suggest that you sit with pen and paper. और जो भी आप देख रहे हैं करते हुए उसको खुद भी कीजिए. Although I'm trying to put make videos of it and put these recordings, trying to put it on a channel on YouTube. I've already put 2 videos. I think for lecture 4 and 5 you would see it up there, but there are certain challenges even for that. So I would really recommend कि क्लास के साथ में ही जो आप अगर अपने आप भी नोट्स ही अपने बनाते चले जाएंगे, दिस वुड बी रियली गुड. एंड एज पर नोट्स इज समथिंग विच यू हैव टू मेक ऑन योर ओन. ये मेरी आसानी के लिए मैंने नोट्स बनाए हैं ताकि एक कोर्स है जिसको ऑन टाइम मैं क्लास में फिनिश कर सकूं. सो ये मेरी आसानी के लिए है. बुक्स में से अलग अलग बुक्स में से पढ़ के ये मैंने कुछ कंसाइज किया है. आप और हम ऑलमोस्ट सेम पेज पे रहें तो जनरली किस बुक से पढ़ाते हैं या नोट्स मैंने अपने किस बुक से बनाए हैं मैं बताता हुआ चलता हूँ. जहाँ पे वो नोट्स मैंने अलग अलग बुक्स से करके बनाए हैं तो आपके लिए डिफ़िकल्ट होगा कई सारी बुक्स को देखना. इसलिए अच्छा होगा कि अभी तक का शुरू का काफ़ी पोर्शन ऐसा था जो कि मल्टीपल बुक्स से लेके था, तो फॉलो विद दैट. लेकिन कोई फर्क नहीं पड़ता, आप किसी भी बुक से पढ़ें, इट वुड बी वन एंड द सेम. इससे कोई परेशानी आपको नहीं आएगी. एंड इफ यू हैव एनी क्वेश्चन देन लेट मी नो. You can let me know within the class. If you have studied beforehand the topic, then we can have discussion right in the class. And if you are revising that topic afterwards, after the class is done, then you can always ask that question through Google Classroom. I mean, that's the preferred platform, that you ask me any question through that, and during the next class I would discuss those questions. ठीक है? If you have any questions or comments, we would take that now. Otherwise, we would move on to another problem, a next problem. So this is okay for everyone. What we have done up till now in this problem on curved submerged surface, that was okay with you. Okay. If that's the case, then let's move on to another problem. Let's move on to problem 2, and let's have a look at it. What we are going to have here. This problem is something like this. आप लोगों ने ये देखा होगा कि जैसे हाई राइजेस अपार्टमेंट बिल्डिंग्स बन रही होती हैं, उसमें बीम और कॉलम खड़े किए जाते हैं. तो लेट्स से अगर सर्कुलर कोई कॉलम बनाया जा रहा है तो आपने देखा होगा कि मोल्ड्स अवेलेबल होते हैं. आर्क्स की फॉर्म में आपने देखा होगा मेटलिक मोल्ड्स अवेलेबल होते हैं. उनको जोड़ा जाता है और स्क्रू कर दिया जाता है, एंड देन कंक्रीट इज बीइंग पोर्ड ऑन दैट. And when these kind of molds are joined together, then they are screwed. So the purpose of the screw is to provide that joining force so that these two molds won't go apart. तो वो कितनी फोर्स है जो कि हमने कंक्रीट डाला उसकी वजह से मोल्ड्स के ऊपर में मोल्ड्स के सरफेसेस पे पड़ रही होगी. अगर हमको वो फोर्स मालूम है तो इन मोल्ड्स को सिक्योर करने के लिए कितनी हमको अपोजिट फोर्स लगानी होगी वो भी निकाल सकते हैं. इट इज जस्ट वन एप्लीकेशन of this problem which we are going to discuss now. So let's look at it. So what I have in front of me is I'm taking a section of this mold. What I'm trying to draw here is a quarter circle. It's a quarter circle. That's what I'm trying to draw. I have concrete in here. Here is my atmospheric surface. Okay. Now, here is my origin, y-axis, x-axis. Okay. At any location r. Okay. R is the radius. Now, if I want to take an element here, let's say I am taking this element here. Okay. Located at theta of certain thickness, I can say that my vertical force which is acting is like this, Fv, and overall force is, elemental force is dF. Okay. This is something which I can find. Now, if that's the case, if that's my problem, then this particular portion which I have drawn here, this red one, it's very small. Let's magnify it, and I can magnify it in this way. Radius r, angle theta. Let's say this overall area is dA. Okay, then I can say that this would also be equal to theta, and this portion would be called dA sine theta, and I can say this one projection as dA cos theta. I can do that. Okay. Now let's look at the problem. The problem is something like this, that you have liquid concrete which is poured into the form shown, the mold. Here radius of this mold is 0.313 meters. Width into the plane of paper is 4.25 meter. Okay, this width is normal to the drawing which you are seeing. What we have to find is vertical force and its line of action. So what do we need to find? We need to find the value of this resultant vertical force and the location of it. That from your origin, let's say your origin is O, then from O, where it is, so x dash we need to find. So that's what we have to find in this problem. I know that pressure is nothing but rho GH. It's my fluid static pressure. Now my vertical force is going to be P times this area. I need to find vertical force, so I am taking the area on which vertical force would be acting, y component of the area, which can be written as rho GH dA sine theta. Okay. By the way, one of the dimension which I missed was h is this dimension here. My dA is equal to width time r d theta. W is the width. H is nothing but r minus y, which would be equal to r minus r sine theta. If that's the case, then I can find my vertical force, and that would be equal to it's a quarter. This is a quarter arc, which means that my theta would go from 0 to pi by 2. Rho g r 1 minus sine theta into sine theta into w r d theta. Okay. Now that's what this is. Now, just as a side note, that for concrete, and if we are solving a problem, if it is given to you in exam, then these are some things which would be given to you. If not, then you can assume them. This is something around 2.5 into 1000 into 9.81. You can find that out. Okay, that's what this is going to be. So in this way you can find your vertical force. What I would like is in this problem, try to find that, okay, how much this is going to be. You just need to put the values now here. The next point was, so first thing is FV, we found out. The next thing which we want to find is the location of FV. To do that, it is quite simple. Try to find the moment. So x dash FV, we need to find this out. This would be equal to rho g r square w 0 to pi by 2, and actually nothing, but I have kept it here, okay, with certain simplifications. Where I can say that my x is equal to r cos theta, okay. So I will find out that x dash fv, again some steps in between, you would find it out to be r rho g r cube w by 6, and from this you can find what is the value of x dash. This is something you just need to plug in the values and you can find that out. So from these two examples you would see that to tackle such kind of problem, there is a way to do that. The way is that you need to find components of the resultant force, which means the vertical component Fv and the horizontal component Fh. And then you also have to find the location of the horizontal component, which is going to be y dash, and the location of the vertical component, which is going to be x dash. Now the location of horizontal component of this resultant force, to find that out, it is quite easy. It doesn't matter what is the shape of your submerged surface. It's curved, it's plane, doesn't matter. You just need to take a vertical projection of it, go to the middle location of it, and see that how much is this middle location away from your free surface. And you can find out the y dash location. Second thing, to find the location of vertical force, that is also simple. You just need to find moment of the resultant force and the moment of the elemental force and equate it, and from there you can find the location of x dash. And that's how you can deal with these problems. Definitely we always need to take an elemental surface and then integrate it, so a little bit of integration is involved in these kind of problems. Any queries here? If you have any questions, then let me know. Okay, if you have no queries, then I think now is the time. Today that's what we have planned, to do some problems on the topic. And from our next class, which is going to be on Wednesday, again on Wednesday, if you would remember, we have changed the timings of our class. So instead of it being from 8:50 to 9:40, actually our class is going to start from 10:30. On Wednesday our class is from 10:30, and we may take more than one period there on Wednesday. So be there on time. Now I would like to you to send your attendances.